All right, so I've taken the liberty of drawing a PT diagram showing the three phases of water. Here's the vapor, here's liquid, here's solid. Recognizing that when we cross over this line from a liquid to a solid, or if we were melt the solid to a liquid, the energy added or removed is referred to as the latent heat of fusion. Latent heat of fusion. This right here, this was called the triple point. Triple point. All three phases can exist simultaneously in discernible phases at the triple point. This right here is known as the critical point. Critical point. Above the critical point, you can't discern any of the phases. So we just call it a fluid because we don't know if it's a liquid or a solid or a vapor. It's just a fluid. When crossing over from the liquid line to the vapor line or from vapor to liquid, this is referred to as the latent heat of vaporization. And then finally, from solid to a vapor or vapor to a solid, this was known as sublimation, and the latent heat addition or removal to go in either direction was called the latent heat of sublimation. Now, I'm sitting here, and it has the fusion line, and that pretty much discusses right there what we talked about. And then the latent heat of fusion is here, where we're going back and forth across this line, recognizing that once I get to a certain energy, there's going to be no change in temperature, and all the energy that I remove to get from here to here is going to be in a latent fashion. And if you'll notice on the bottom of that page, right down here, it says at atmospheric pressure, as you remove energy, once you reach 32 degrees, the latent heat of fusion for ice is 144.5 BTUs per pound mass. So that's a pretty neat number. Now, not operationally significant since we don't deal with a lot of ice in our cycle. Then on the right-hand side of that page, the right-hand side of here, it's dealing with the latent heat of vaporization line. And we know that vaporization is where once we reach the saturated liquid point that there is a latent heat addition or removal. And if I was going from a liquid to a vapor, that would be a latent heat addition. If I was going from a vapor and condensing it back to a liquid, that would be a latent heat removal. It occurs at a constant temperature. And the second paragraph on the right there, pretty interesting. It tells us at atmospheric pressure and 212 degrees, the latent heat of vaporization of water is 970 BTUs per pound mass. Very important right there. It says, can you define the latent heat of vaporization? And there's an important note. We should note that at higher pressures, the latent heat of vaporization is lower. That means it requires less enthalpy to turn a saturated water to a saturated vapor at higher pressure. And then finally, there's a knowledge requirement to understand this vaporization line. Now, you can see it very simply on a PT diagram. Vaporization is just turning a liquid to a vapor. We could change its name to the condensation line. If I was going from vapor back to a liquid, I was condensing the vapor. And we'll look at these same things on a TS diagram here in the next video.